Welcome to this experimental eclipsing binaries discussion focused on systems that have poorly known or maybe no good ephemeris. We have a series of presenters this morning. Oh, by the way, you may not be able to tell, there are 21 attendees for this meeting, so we're already pretty successful at getting an audience. We have 5 presenters scheduled on this general topic of eclipsing binaries. What we'll do is let each of the speakers show some slides and make his presentation. I'll keep track for people who have comments or questions, and then after each presenter, we'll take a few questions or comments. I will try to do that by unmuting you so you can actually say your question yourself. We probably won't get to everybody during that period, but after all the presentations are done, we'll stick around for an open discussion for anything that we've missed. Thank all of you attenders for coming. Thank all of our speakers for volunteering to do this. For AAVSO to allowing them to be the guinea pigs with this new mode of communication. Thanks to the Society for Astronomical Sciences, who's paying for the GoToWebinar software today. So I am going to unshow my screen and let Gary Billings take over. To talk about his approach to dealing with out-of-date ephemerides. Gary, you should be able to show you.
Okay, so this is a little talk about one man's experience observing lesser observed eclipsing binaries. Don't take this as being the only way to do it. You may very well find better tools, better insights, but maybe this is a useful starting place. Okay, so I'm going to do a little bit of a general introduction here, and then get into the real specifics of how I plan for eclipsing binaries when the eclipses are hard to predict. So I'll start with talking about what observations we want to make, what stars to observe, and then how to plan the time that you're going to observe and what to do if the eclipses are wrong. And all of this is in the context of what I do. But one of the great things about our hobby is we each get to choose, and you may well want to do something different. Okay, what observations do we want to make? Well, AAVSO is mostly about photometry, measuring the brightness of the stars and how it changes. But at one level, the most superficial level, you could say that the light curve of an eclipsing binary is pretty much identical in every cycle. Now, there's lots of caveats there, which I'll skip for the moment. But given that, you could say once you've seen one cycle, you've seen them all. But apart from the fact that that isn't entirely true, there is still something else that's very useful to do, and that is to very accurately measure the time of those eclipses. Because in fact, for many eclipsing binaries, the period is not precisely constant. It does vary, and the way it varies tells us about the orbits, about possible mass transfers between the stars, and so on. So just getting the times of these eclipses is very interesting. So the most useful way of getting the most precise and accurate times for those eclipses is to do time series photometry really intensely on one star through the night. So you've got a densely sampled light curve through the eclipse. And from that, you can determine the time of minimum. I note that, excuse me, that isn't the only way to do it. You could just observe at random times for multiple years and build up a light curve and determine a time of minimum. And that's how most of these were discovered. But the most accurate times of minima, which I think are the most useful, come from intense observing through individual eclipses. Now, back to my my comment that you've seen the light curve once, you've seen them all. Well, of course, that's not true, because you can have intrinsic variability. Many of these binaries, one star might be a delta Scuti variable, or they could have significant spots that change with time, or even the eclipse depths can change due to apsidal rotation and precession. And there's a small list of eclipsing binaries who've even stopped eclipsing because the orbits have shifted around and our line of sight doesn't let us see eclipses anymore. So there's a whole bunch of stuff you can do that's not just timing of eclipses, but today I'm talking about timing of eclipses. Okay. So which stars should you observe? Which eclipsing binaries? And there's two approaches. One is to observe stars that have been observed for a long time. And Jerry Samolik is going to talk about this more later, because he's on a first name basis with most of these stars. He knows them well, and he produces an ephemeris for a list of about 200 that really makes your observing planning easier. And it is definitely valuable to continue stars that already have a long history, because human life is short compared to the life of a star. And the best way to get 150 years of observations is to start young and start with a star that already has 100 years of observations. So these stars are ones with a long observing history that should be continued. It's easier for you to plan, there's less uncertainty, and there's lower risk of observing for a whole night and not seeing anything happen. On the other hand, my preference is to observe stars that have very little observing history. And one reason is a single observation could double the amount of observing history of the eclipse timings for this star. So that's kind of fun. And also just to flesh out the population statistics. When you go to a catalog of all the eclipsing binary, there's many that don't even have a period recorded in the catalog. And Sebastian is going to talk about this a bit more later. Also, adding a little bit to the observing history is going to help future observers, because they won't have to spend many nights trying to find when the eclipses are occurring. And one may well discover interesting behavior in this star. You might find that it's a total eclipser, which is always more useful to modelers. You might find that it has apsidal rotation, or it has a displaced secondary, or whatever. So there's lots to discover, but the downside is the predictions can be quite inaccurate. Sometimes you can do an all-night run when the eclipse was supposed to occur in the middle of the night, and you won't see any variation at all. So it's these stars with little history that I'm mostly going to focus on, because they're what I love. And I'm going to talk a bit about those problems of when the eclipses can't be predicted very well. This is a slide that don't bother to read it right now, but I'll make this little PowerPoint available, and this lists places to go to get more information about O-C diagrams, which are very useful, and also an online tool where you can get an O-C diagram for stars based on the observations that have already been published in the open literature. And down at the bottom, there's a site that can also give you an O-C diagram, and it will give you a prediction for the next 10 or so eclipses. So those are just useful resources for you. Okay, really the only point I want to make here is the way that we predict eclipses is with that, a sample equation is in that gray box, the GCVS elements for V398 CAM, where the time of an eclipse is given by a big long number that is the Julian date of an eclipse that we're calling the primary eclipse at cycle 0. We call that the epoch. So the time of some eclipse is given by the epoch plus the period times the number of cycles since that epoch. So to get an eclipse for prediction for tonight, you have to find the right cycle number, and you can do that by trial and error or a little bit of math. And then that equation will tell you the exact Julian date when the decimals give you the fraction of a day for the upcoming eclipse. And that equation is just the equation of a straight line. It's just y equals mx plus b, where b is the epoch and m is the period. So it's just useful to work with that little equation and know how to turn it around and solve for a different variable. This is the kind of sum assembly required stuff that you get into when you're observing stars with an uncertain ephemeris. And in fact, one thing you can do with that equation, and Eric is going to speak about his experiences doing just this a little later, is you can turn the equation around. And if you've observed an eclipse at some time t, you subtract the epoch, which is t0, divide by the period, and then take the decimal part of that. And that tells you what fraction of a cycle, where the phase in units of cycles. So where in a cycle does your observation fit, given those elements, the elements being t naught and p. And up in the upper right, I show you how I enter that equation into Excel. It's actually pretty easy to do. So if you've observed a star at some random time and you wonder where in the cycle that would have landed, this equation will tell you what phase you were at. And you can also use that to plan observations if you're trying to distribute them across the cycle. Okay, getting on to my own observing. So based on what I've said, I observe times of minima, usually with an all-night time series, to get information that'll let us revise the elements to make better predictions for the future and to identify interesting stars. The stars I go after, I draw them from what I call the Otero Plus list. This is a spreadsheet that you can find on the AAVSO EB web pages. And it's a list of over 1,000 stars that Sebastian Otero and his co-authors published in the early 2000s. What they did was they mined the NSVS and ASAS photometry databases, found stars that were varying, identified which ones were eclipsing binaries, and then published epochs and periods for them. And we can use those epochs and periods to predict when future eclipses are going to occur. One thing that's great about that list is that it fits a magnitude range of a typical amateur's telescope. They're sort of 9 to 13-ish, so right in our sweet spot. And some of them, there has been no eclipse time published since the discovery. And those discoveries, many of them were based on data only from 1999. So you can easily find that the eclipses will be hours off. And if it's say a star with an 8-day period, it could easily be 12 hours off. So there's a good challenge there. Getting really specific to me, I live at 51 North, and I can observe below the pole. So I observe stars in the circumpolar constellations. And I like longer period stars just because less people do them. And so it's more likely that I can double the observing history with one night of work or a few nights of work. But the downside is when the ephemeris is off, as I said before, I might find no variation at all during one night. Really getting into the nitty-gritty of how do I plan a night. This is kind of my step-by-step process. So I use those elements from Sebastian. He actually gave me a list of all 1,000 of them in the spreadsheet, and that's what's on the AAVSO webpage. And then I use a script to select targets in a certain constellation, and then tell me all of the ones from that list in that constellation that are going to eclipse tonight. Now, you could do that in a spreadsheet if you wish, and it might be better to select on something other than constellation, but this works for me. Then I check to see if I've already observed it. You know, did I observe it 3 years ago and find that it came 2 hours later than the prediction? If so, well, then I'll modify the prediction and contemplate whether this is still a good target for tonight. Then I go to those 2 websites that I listed earlier. The Krakow site or the Bruno site, and both of them will put up an O-C diagram showing all the observations that they've gleaned from the published literature. And they're plotted as an O-C diagram, which means they show how much the time of the eclipses that they found differ from the prediction that would have been made for that night. And based on those O-C diagrams, I can assess how much observing history there is, whether the star looks like it's just straight line, and whether it's worth observing and how difficult it's going to be to get an observation, and also whether my prediction, the prediction I'm using, fits with the existing data or not. So what I'll do is I will take the prediction that I have for the star that I'm considering for tonight. I'll go to that Bruno O-C gateway site, and I'll enter the prediction as if it's a real observation. And this site doesn't store the data, it just will add it to the plot. So I'll enter the prediction for tonight and see where that would land on the O-C diagram. And if it's roughly in alignment, well, then I figure I've got good odds of actually getting the eclipse. If it's wildly different, then I've got to do some investigating and think about whether I trust the prediction or the data that's there. So I have to make an assessment of what I think of the data. And if there's been no observations at all since the discovery, there's another resource. You can go to the Assassin website and you can just type in a variable star name, and it will give you a light curve based on their data, which looks like goes back about 4 years now. And very often they will put up a nicely phased light curve. Often it's better than any light curve that exists for that star in any publication. Other times, and I don't know the rhyme or reason to this, their automatic software is unable to determine a phase, a period, and an epoch for the data. So it'll just show the observations over the past 4 years. And in that case, you can download the data and use the period and epoch, say from VSX, which is often the data that Sebastian generated, or some other source, and make a phase light curve yourself and refine the prediction for tonight and so on, and assess whether you think it's worth doing. So this page really describes my daily step-by-step process if I'm going to observe for tonight. Now getting on to actually looking at some data. This happens to be a composite of a couple of screen grabs from the Assassin website for V407 draw. And they've made, on the left-hand graph there, that's what their data looks like. Data acquired at random times over the past 4 years, and their software goes in, and I believe this all happens automatically. They determined a phase, a epoch, and a period, and moved all those data points so that it's as if they were taken within one cycle of 1.2 days, and then they plot that phased light curve. And that's what you have at the lower right. So you can see they've made a beautiful light curve with that data. But still, you can see there's relatively few points in the depths of the eclipse, and they were randomly gathered over 4 years. So one intense time series through the bottom of that eclipse is going to give us a better eclipse time than you can get from their data set. But their data set is invaluable in helping you plan. Okay, now these are a couple of screen grabs from the Bruno site. On the left, CW-SEP. Let's say that I was contemplating observing CW-SEP. Well, as soon as I get back this web page, I see that this is a fairly well-observed star. Every symbol on that graph is a time of minimum observation. The filled black circles are for primary eclipses, the open circles are secondaries, and what this kind of O-C diagram is telling you is that it's an eccentric system with apsidal motion, and the two eclipses are varying around a mean period with a quasi-sinusoidal pattern, and they're roughly reflections of each other. So this would tell me, hey, this is a well-observed system. This isn't my personal thing that I want to do, so I wouldn't choose to observe this system, probably. But this tells you how intensely it's being observed, and is it being observed fairly recently. Always with the caveat that these websites are based on information they've gleaned from the literature, which is always a couple of years behind actual observing. On the right is an example more like what I usually go after. V398 CAM, when I type it in, they show only 2 points. One was from Sebastian Otero, and that looks like 1999 data, so that was probably NSVS data, and one from about 10 years later. Having only 2 points, they don't plot an O-C diagram, but what I can do is I can say, okay, I have a prediction for tonight. Let me just type that in and see how it would jive with their 2 points. And so on the next slide, this is what it would look like if I typed in a point. Let's say this point was a prediction. This would tell me if it comes in as predicted, how will that fit with the existing data? And in this case, it's not bad. Now, I've kind of lied to you because this wasn't a prediction. This is actually a real data point that I got from 2019, and my data point came in 23 minutes late. Sorry, 23 minutes early to the published elements, which isn't bad. And so what I would take away from this is another observation this year. Yeah, observe it based on the prediction, but expect it to be half an hour early. Okay, one more. I think this is my final slide. This shows what I did with V407 draw. Down at the lower left, just out of interest, I posted the light curve that Sebastian made and published. Again, this was the NSVS data, which is all from 1999, and he published this in OEJV 91. And so that was a year's worth of observations taken at random times, and he determined a period and epoch and folded all the data into one cycle and made this phased light curve. And so at the Bruno site, it initially only had 1 point, his data point from 1999. So again, it wouldn't plot a graph, but here I've now observed it several times in recent years, and I've now entered my observations, and they're actually plotting, they're all collinear, which means they're self-consistent, which is good. They don't point exactly at Sebastian's data point, and I need to investigate that. I'm not sure if it just reflects the uncertainty in the data that he was working with, or maybe there's been a period change since then. I don't know. But my data points show that an eclipse on this star is going to come in at about 3 hours later than a prediction using these elements. So I need to factor that into future observations, and I need to publish this and suggest an improved set of elements in VSX and so on. So that is a very quick run through, probably too quick, of the rationale and the methods that I use to tackle these stars that have uncertain predicted eclipse times. But just to summarize, for eclipsing binaries, I'd say there's fun here for everyone. You can observe legacy stars, or you can observe less observed stars. Each have their own merits. For the less observed stars, often a bit of detective work can be required, but it's really just based on that linear, slope of a straight line, linear ephemeris equation, and the O-C diagrams. And there are online tools and resources that you can use to help you do that. And so that's all I plan to say. Bob, if you can take away my screen, I'll figure out how to get my my mouse back.
Okay, before I take away your screen, does anybody have any questions for Gary? If you hit the raise hand button on your dashboard, I will try to unmute you. Mark Blackford.
Hi, Mark.
Mark, you are unmuted. Well, you're unmuted on my end anyhow. Mark, we're not hearing you. Maybe you should type your question into the questions box. Well, I'm not hearing Mark. Mark,
Well,
type a question and we'll get back to you. Wayne Green has a question. Let me unmute you. Go for it, Wayne. Wayne?
Can you hear me okay now?
We do.
Okay.
yes.
This is just a sound check. So my muted button went green when you unmuted me. However, my mute button on my headset had gotten mashed, and that was this small fumble. So that is all I wanted to do. Take it away.
Okay. Thank you very much, sir. Any other questions? Well, it looks like you've covered the waterfront, Gary. Okay, our next speaker is Jerry Samalek, who will talk about the legacy program. And Jerry, I have made you the presenter.
All right, let me find my PowerPoint here. Is everybody seeing that?
Got
Yes.
it.
All right. The legacy program really got its start late 50s into the 1960s when Joe Ashbrook was publishing times of minima and Sky and Telescope. At that time, the AAVSO really didn't have any type of program for eclipsing binaries. About that time, though, the work that Joe was doing did inspire the formation of a committee, and that's basically where the legacy program came from. We had Dave Williams, Marv Baldwin did quite a bit of observing through the 60s, and then in the 70s, we were adding a bunch of stars. So most of the stars on the legacy program have at least 40, sometimes over 50 years worth of observations. So I'm just going to go through a few examples of what we have seen with these stars. VVUMA is a typical, this is O-E diagram, by the way. And we see a nice sinusoidal shape of the graph, which makes you think that there's maybe an extra object in the system that's cycling it back and forth, causing the light time to change. The earlier data has a lot more scatter being visual. The later observations are CCD. This is an example of a star that's similar to what Gary talked about, where we have a elliptical orbit, and we certainly have some apsidal motion going on. Now, the earlier visual data just seemed to be very widely scattered, but once we got going with the CCD, we could easily distinguish between the primaries and the secondary, with the blue being the primary and the red being the secondary. So it looks like we have an apsidal period somewhere on the order of 40 years. So if we keep going, we should be able to define that a whole lot better. It's another star that we didn't realize had an observable secondary for a while because it was offset from the primary. Again, it looks like another case with the apsidal motion. RUMON is another apsidal motion case, but this one's particularly interesting because if you look at the secondaries and the primaries, the curves really are not mirrors of each other, which is what we would expect. So I'm not sure what else might be going on here, but this is a case where it's going to take a long time to work it out because the estimated apsidal period is over 350 years. The circled times the minimum are CCD. The other thing interesting is when you look at where the two graphs cross each other, that would be when the major axis of the orbits were in line with our line of sight. And so the secondary and primary happening had a half orbit apart from each other. But because of Kepler's laws, the orbital velocities are quite a bit different. And so when we look at the light curve, the primary in blue has a significantly shorter eclipse than the secondary in red. Now, sometime over the next 75 years or so, I expect these two light curves are going to equalize in duration and then reverse. Why Leo is a star where it looked like there was some kind of cyclical, I don't know if you can see my mouse.
Yes.
There was some kind of cyclical action going on. Then there was a huge increase and a huge decrease, and there's probably still some kind of cyclical action, but it's obviously that something really has changed dramatically with the period. And this is one of the objectives of the Legacy program, is to watch stars for a long time to really understand what's going on. It is interesting that when you talk about the human lifetime, this is all within my human lifetime. So stars can change very rapidly. V342 Aquila is a star that we don't get too many observations of because it's a long eclipse with a 3-hour totality. It also has a relatively bright star very near the variable. So with your CCD, you need a longer focal length telescope with small pixels to get separation between the variable and the nearby star. But you can see again that it looks like there's some type of long period oscillation going on, but there's also something else going on in these areas. And not quite sure what it all means, but my job is just to document what's happening, and then we'll let the theoretical people figure it out. This is another star that just seems to be doing random changes of period. And one thing that I really want to point out with this particular O-C plot is a lot of people try to fit curves to these things, but it looks like we've got a segment here, which is definitely a straight line, a straight line, a straight line. And so what we seem to have here is a star that's orbiting along, and then there's some type of mass ejection that changes the angular momentum of the system. Then it stabilizes and it keeps that new period for a while. Then there's another event. And by watching this, this is probably 40 years worth of data. We can document all the different changes that go on. Now, the other thing that can happen is if you look at the most recent change, had we not been observing this and gone with the ephemeris, we would quickly find that we were not going to be predicting eclipses accurately anymore. This is why we like to try to get these stars observed, maybe one light curve, one time of minimum every season or two. And that's usually enough that we can keep track of what's going on with them. Oh, I threw this one in because this is a cataclysmic variable that also eclipses. And so you do get some variations outside of eclipse, but I also noticed that you get a steeper decline, and then typically we see this little delay coming back up. And I keep speculating whether what we're seeing is that the star has an accretion disk around it with a hot spot, and this is where it takes a little longer for the hot spot to come out from behind the star that's doing the eclipsing. One challenge with the cataclysmics is they tend to have some very short periods. This is a single night, and these eclipses are only 4.5 hours apart. And when you get into fainter stars, if you go with too long of an exposure, it's really hard to get enough points during the eclipse because the eclipses can be very short. I think on UGEM, the eclipse only lasts 20 minutes. This is an O-C plot for the same star. So you can see that there has been some changes going on over the past few decades. I'll finish up with a star that's not really on the Legacy program, but it's been a favorite of mine for quite a while. In fact, the current eclipse is still underway, which is the eclipse shown in the yellow points. And this is a dramatic case where each eclipse looks completely different. And certainly this current eclipse is a much longer duration and seems to have gotten underway a whole lot earlier. The model for this star, or one of the models, is that there's a disk that's actually doing the eclipsing, and the disk itself is precessing. So every time that an eclipse occurs, we're seeing different geometry, a completely different shape, and that's causing all the changes. The eclipse occurs every 5.6 years. So that's a brief view as to what we're doing with the legacy stars. We've got a little over 200 stars on the program, and we continue to observe and publish times of minimum, typically twice a year. Although the papers we publish for times of minimum are not restricted to the legacy stars, we'll pretty much publish any time of minimum that an observer wants me to do.
Thank you very much, Jerry. We have one question from Mark Blackford that was directed at Gary Billings, but both of you may want to weigh in on it. The question is there any point in observing eclipsing binaries that do not have an AAVSO identification number, an AUID?
I would say absolutely. You can always request one.
Yeah, we can assign one right away.
Okay. Who do they send the information to?
We have, if you have a VSX account, we have a link to request an AUID, and we got a notification at the moment, and we assign it if we are available at that time. It's automatic, so it's very quick.
As long as the star is available on VSX, you just type in the star that you want to look for. When you go to the page, as long as you're logged in, if it doesn't have an AUID, you can request one, and that's it.
Perfect. Audience, any other questions or comments? I don't think I see any hands raised here. Okay, I guess not. If you think of one, feel free to type it into the question box and we will get to it. Our next speaker is Sebastian Otero, who will talk about how to search VSX for eclipsing binaries with no ephemeris at all.
Okay, can you see my screen right now?
Yes.
Okay, well, Gary and Jerry were talking about stars with periods, little observing history or long observing history, and I'm going to focus on those with no observing history at all, or actually some observing history because we know they are eclipsing binaries, but for most of them we have only 1 or 2 eclipses recorded, so no reliable period is published anywhere. So those could be interesting targets. Actually, they are my favorite. I loved. I talk in past tense because I am not observing anymore actually, but several years ago, I really had fun going out every night and trying to get eclipses for those eclipsing binaries without any period published. So I want to share my enthusiasm about these stars with the public, and I will show you how to search VSX for those objects. First of all, you have to go to the VSX search page. You have to click on the More button here twice to get extended search options. Twice here, and as you see, we have a lot of options now. You can make searches for variability type, for maximum magnitude, for period, any kind of searches. And what we're interested in here is to search for variables without periods. So we will type 0 and 0 here in the period field, period between 0 and 0. This way we will get results of eclipsing binaries without periods. A first approach will be to search by group. As you see here, we can search by different variable star types: pulsating, eclipsing, Cepheids, cataclysmic variables. Well, of course, we are now going to select eclipsing binaries, 0 period, and then we can order the results by GCBS sequence, alphanumeric, position, or whatever we want. We can select maximum magnitude to use it as an example. Let's do the search. And we have more than 2,000 records. Does this mean that all these 2,000 records do not have a period? Not actually right now. Why? Because some of these may have periods in the GCBS, but they weren't still imported to BSX. So we need to make some preliminary check right now to see if they have or not have any period in the literature. I am going to change this week or the next one because I am working with the GCBS latest version, and this problem will go away soon. So if you're going to look for stars right now, you need to check the GCBS, but if not, there will be no problem. As you see, we have a list of stars here. Some are suspected variables, the ones in red, and some are confirmed variables, those in green, the V letter and the S letter. These stars have no period. Some don't even have a magnitude. How can that be possible? Well, this has to do with the list, the original list that we imported to BSX. Sometimes, as weird as it may seem, those lists doesn't have a magnitude. So this is what we got. So a good contribution to BSX would be to revise these entries and provide a magnitude range. As you see, we have all kinds of stars. You see the names here, some new suspected variables, some stars with catalog names like the 2MASS designation, GSC, Hubble star, Guide star catalog designations, and other kind of stars. We also see some GCBS variables here. So we have more than 2,000 examples. We have all types of variables here because we made a search using the Eclipsing binary, We made a search using the Eclipsing binary groups, and this includes EA, algol types, EB, EW, all types of Eclipsing binaries are included in our results. But we can make a different search if we want to get, for instance, only AA type variables, algol type variables. We can type EA here. We can also use the % symbol, which will allow us to find some algol type binaries, but with some other variability types. For instance, you were mentioning before that there are eclipsing binaries with delta Scuti components. Well, you can find it this way. You can find them. So let's try this search now. Only algol types, go. And we have almost 1,000 variables, half the number of results of the previous search. It's interesting that, as you see, we have here some results with white dwarf binaries, semi-detached binaries, but all without any period. Okay, let me show you an example of what I mentioned before. Some of these GCBS stars may have a period. So we may click here to make sure they have or not have a period. We go to the variable star page, and we can use the external links, the BSX external links, to go directly to the GCBS page. We don't need to go to each catalog page individually. We can use the external links. It's much easier and faster. So let's click here. And here we see that the star did have a period, 3.6 days. So if you are only looking for stars without periods, we will get rid of this one. So as I told you before, for this week, if you're planning to do this, check the GCPS. If not, wait another week and we will get rid of this problem. So if you want to check any of these other variables like Catalina variables or Corot variables, as you see here, well, they do not have a period. So depending on your setup or your limiting magnitude, you may want to check the magnitude range. You can sort the results here by magnitude or variable type or whatever. Let's try magnitude. So you will have the brightest ones at the top and the faintest ones below, and you will be able to select the ones you really want to observe. Just check the amplitudes too to see if you can really detect those changes. Some of them won't have an amplitude listed, but some others will. Check this one, almost 3 magnitudes, an eclipse of almost 3 magnitudes, very interesting. So we have all kinds of stars here. You can select them as you want, as you see fit. Let me show you some examples. For instance, I was checking before this one. This is a Gaia star. As you see, it is an EA without period. We can go to the Gaia alerts page using this link, and we will see the light curve. As you see here, only 2 eclipses recorded in almost 5 years, or more than 5 years. So we don't have a period here because we only have 2 eclipses. But see that the eclipses have almost 3 magnitudes in amplitude. So this is very interesting, a very long period variable. Actually, most of the stars in these searches will turn out to be long period variables. And that's why we don't have periods published, because the eclipses are very, 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 very rare. And you will have to be patient to detect these eclipses. This is a different approach than the approach used by Gary and Jerry, because you will have to observe as much as possible, as many nights as possible, and as long as possible to detect one of these eclipses. It takes a lot of luck, actually, because you may be a whole month or 2 months or 3 months and you won't detect anything. See that in this example, the eclipses are separated by, are separated by 2 years. This doesn't mean that the period is 2 years. There may be some eclipse here, hidden here, or so, but you never know. You need to observe. So these are very interesting, but they are not predictable. So you need to go out and observe. What else? It's important also, as Gary mentioned in his talk, that all this information that we acquire or the information that they are getting is included in BSX2. So I urge you to submit a revision to BSX of the stars that you are observing, because that way we will be able to provide up-to-date ephemeris in BSX. Having said that, I would like to show you an example of, if you don't know, you may find ephemeris using BSX. Let's try to search for some variables with periods to try that. Let's try between 1 and 2 days. Yes, search. Okay, let's go to some of these, any of these, just to check the ephemeris. Here in the epoch field, you will find this button here, this link at the right. It's called ephemeris. You click on that, and the a pop-up window will come up, and you will see a list with the time of mid-eclipse, the epoch of mid-eclipse. For the ones that have an eclipse duration published here, let's try to find one of those. Oh, sorry. Let's try again. Here. Let's see if this one has an eclipse duration. No, not all the stars in VSX has an eclipse duration, but it's interesting because that way you can plan your observations completely from the beginning of the eclipse to the end of the eclipse. This wasn't planned, so it's possible that I have a hard time finding one. Oh my God, so many stars without an eclipse duration. I didn't know that. It's easy. I will look for Algol. This one has an eclipse duration, and I will show you the example. So, oh, sorry, Algol. Algol. Oh, what's happening here? What I'm doing wrong? I am teaching you how to use VSX, and I can do it. Oh, okay. I have these two fields completed, and that's why Algol doesn't have a period between 1 and 2 days. That was the reason. Here it is. Now here, the ephemeris field will show you here the beginning of the eclipse. Now we are April 15. The following eclipse will be April 17 at 5:51 p.m. The start of the eclipse, mid-eclipse here, and the end of the eclipse here. So this is a very interesting tool, but as our colleagues mentioned before, the only problem that we may find is that VSX is not completely up to date with some of the ephemeris. Some may be wrong because we are using some epochs from the last century, from the 20th century. So it's important to keep this information updated so these ephemeris are actually useful to plan observations. So we are trying as much as we can to use the online surveys to update VSX. I mean, ASA3, ISASIN, NSVS, or all the surveys available to improve these results. And talking about surveys, before finishing my presentation, I wanted to make sure that you know about the survey data availability, because if you want to observe stars without periods, you need to know that some of the stars in these leads may actually have periods. If you look for data in ASASIN, for instance, or ASAS3 or Catalina survey, or test data recently available for bright stars. So the targets that will benefit the most from your observations are stars brighter than 9 or 10th magnitude, because they won't have observations available through the ASASIN page, or stars fainter than 16 magnitude. If your targets have magnitude between 10 and 16, they are probably going to have eclipses recorded in ASASIN. So it's better that you go first to the ASASIN pages and download the data and try to find a period from those observations. You can also do that using the external links here. Every time you select here, you will have a lot of surveys here with observations. In the case of Algol, of course, ASASIN will not return any useful result because this is a 3rd magnitude star. So don't waste your time looking for data, but you have the external link there available for any other star between 9 and 16 magnitude. And you also have links to ASAS3 and other databases. So if after checking these surveys, you still want to observe these stars, you need to observe as often as possible to find an eclipse. I succeeded several years ago with almost 10 stars, and I did it only visually. So you can also do it visually. It's not that you need to have a CCD or DSLR camera to find an eclipse. If the amplitude is large enough, you can detect them. So it's a very interesting area. I think that's it. Let me check. Yeah, I think that's all I wanted to share with you.
Thank you very much, Sebastian. Does anybody have any questions for Sebastian? Click your raise hand button and I'll, Ed Wiley does have a question. Okay, Ed, you're unmuted.
I don't really have so much of a question, but just to congratulate Sebastian on his work. I use this extensively. I found AUIDs are easy to obtain, and then I immediately ported over to the sequence team because I'm lazy. That's all I had to say.
Thanks, Ed. Yes.
Any other questions from the audience? I don't see any.
Actually, I'd like to interject a comment. When you're doing newly discovered stars or suspected eclipsing stars, I've had 2 cases where observers have sent me data on stars that look very erratic, and it turns out they aren't eclipser at all, but they're multi-mode Delta Scuti stars. So keep an open mind when you're observing.
Yeah, we even have red variables classified as eclipsing binaries. So anything is possible, especially when we talk about the new suspected variables. There are all kinds of stars hidden there, and they are not eclipsing. So.
Yeah. Gregory Conrad has a question. Gregory, you're unmuted. At least you're unmuted on my end. You may have to unmute on your end also, Gregory. No, we're not hearing you, Gregory. Maybe the best option is to type in the question, and I will pose it after the next conversation. Sebastian, I have a question for you, or a clarification. On the ephemeris line for eclipsing stars, the time in the ephemeris is always supposed to be the time of the primary minimum.
Yes. Yes.
Pulsating stars also have an ephemeris click. Is that the maximum or the minimum?
For eclipsing binaries, it's always, of course, the minimum, but for pulsating variables, it's always the maximum, except in arbitrary stars. You know, the standard is that for arbitraries and for dark spotted variables, we give times of minimum, and for pulsating variables. And for bright spotted variables like ACV stars, for instance, we give times of maximum. So that's the standards.
Gregory Conrad is asking for more information about the process to update the ephemeris in VSX. I guess if he's made observations that make an update appropriate, how should he communicate that?
The best way would be to submit a revision to VSX. You have to have a VSX account, log into VSX, go to the star page, and you have a link there who says revise. You click on that, a form will come up, and you will be able to add the new information that we have, a phase plot. We require a phase plot supporting the new elements that you have found. And then you can change the period, add the new period, and the new epoch if you have one. So and then you click on submit, and we check that. We review your revision, and the new information will be available online after we accept it. So that's in short the process. We have an online manual, a VSX manual available, so you can read it before trying, because it will explain a lot of your doubts there, and it will make the process faster. But basically, it's that. And for known variables, like in this case, it would be important that since we already have elements, we need you to improve them. So it's important if you combine your new observations with any available online observations, AAVSO, AAVSO3, because that way we will be really improve what we already have. because one of the problems that we find nowadays is that many new lists of variable stars are published anywhere with information on a lot of known variables, but for instance, using a time span of only a month. And we have data spanning years in VSX, and our current data are better than the data that it's being published in such papers. So it's not worth to revise the current information with that information. So we need to make sure that what you will be submitting, it will improve what we already have. So that's why we recommend to combine data to increase the time span of the observations. Several years is not the same as just 2 nights. Some people submit revisions based on a single eclipse, 2 eclipses, and that period is not going to be better because we have observations spanning years in VSX.
Now, Sebastian, you mentioned a VSX user ID. Who is eligible for that, and what if a person does not have one?
No, anyone, it's public. You can log in and create an account. There's nothing to prevent you from doing that. And as long as you read information and submit the data, we will review it and we'll tell you if something is wrong and what needs to be changed. So we are very careful with that. And maybe sometimes there will be 3, 4, 5 emails between you and I until the submission is ready to be approved. But everybody can do it. So there's no restriction in that.
Great. Thank you very much. Next up is Eric Dose, who will talk about how he captures EB phases. Eric, you are now the presenter.
Very good. So let's talk about a situation that's been brought up by almost everybody so far. You've got a perfectly good eclipsing binary. You want to observe it. You don't know why. It's at a convenient place in the sky. Maybe it has your postal code, but you don't trust the phase or the ephemeris, and maybe you don't even trust the eclipse period. Don't fret. You should capture the phase. And here's how I've done this perhaps 15 or 20 times for 15 or 20 eclipsing binaries. Now, this kind of observing is very different from monitoring known eclipsing binaries. In those cases, when you're monitoring legacy eclipsing binaries and so on, you want to get as dense a cadence as you can near the minimum so that you get the best possible minimum time. However, when you're capturing phase, you can work the observing in between your other observations. Maybe you're doing other eclipsing binaries. I specialize in Myras, so I get these 5 and 10 minute gaps in my schedule between the other stars, and I sometimes fill those by getting almost random observations of a particular eclipsing binary that needs ephemeris improvement. And in my humble opinion, I think that AAVSO, perhaps the section in VSX, should give credit in the future when those are obtained. So here's how I do this. Say I know an old ephemeris and I know a pretty good period from VSX, from Assassin, from GCVS, wherever. But there's a problem here in that this is 80 years old, and you're not going to be able to trust that. You might be able to trust the period, however. And you probably need an approximate magnitude range if you can trust that, so that you can set your exposure times in the CCD, and you take observations. Now, the 2 columns I have here in this mini Excel spreadsheet are just a record of, in this case, my own observations taken almost random nights, almost random times. And all I start with is the Julian date and V magnitude. And then from those, you can calculate these 2 middle columns. And you do that in just the way that Jerry and Gary suggested. You take the JD of your observation, you subtract some reference JD, it almost doesn't matter what it is. May as well use the reference JD from VSX, divide by the putative period, and you get N in the second column there, which is the number of cycles as a floating point number, as a whole number, as a rational number. And then you take the reference phase, which is just a fractional part of N. And you plot those. The things in that big yellow square rectangle, you plot those, and you get this. This is for V367 Cassiopeia, and you can't tell which is the first, second, and third observation in here, plotted versus in V versus phase, but you can tell which is the last one. The last one is the low one at 14.4 magnitudes, because at this point I've captured one of the minima. It may be off by a few hundredths of a phase unit, but it's close enough that you can now do a dense observation. That's what you're looking for. And you probably should do a dense observation at about 0.35. That may or may not be the secondary minimum there, but those are the best places to start your now dense, high cadence search for an accurate minimum time. So that's one that I was actually able to capture. When you know the eclipsing period, or you think you do, then a wide range of times is more important than sheer number of observations. Consider a cadence of 30 or 45 minutes, but use your phase graph as you build it to choose the next observation times. Fill in gaps in your phase graph and fit these observations between your other observations that you're doing. Now, in fact, an irregular cadence is actually preferable to a very, very regular cadence. Don't worry about it if you're a few hundredths of a phase unit off from where you would have preferred to be, because if you end up doing a periodogram, if you end up doing some kind of Fourier analysis to capture sparse data, actually an irregular cadence is actually preferable because it beats down the aliasing. Please report your data to the AAVSO, the AID, even if they're baseline results. Going back to the previous slide, the points along 13.8, the baseline points, are equally important because they help the minimum observations when you finally get them to stand out more starkly. And consider cooperating with other observers with particularly at other longitudes so that you can cover more of the 24-hour period. And that's pretty important in some cases. For example, this one. Now, this is the same top data that I showed, but for a different star. And experienced observers of periodic stars, one number on this will jump out at you, and it's either the 0.99 days or the 23.8 hours, which is really kind of unfortunate and known to cause problems because every night you're going to be observing it at about the same phase. That's a problem, but not insurmountable. If over a month or 6 weeks of observing every few nights, this is all you can get, sometimes it's good enough. I think you can almost squint and see where the primary minimum and the secondary minimum are. And if you don't believe it, get a dense cadence and prove it. That will establish a very hard to establish ephemeris. End period. Now, the harder case, when you don't know the period, you can't construct a phase diagram. It's much harder, and it's probably not a good choice for your first phase capture attempt. Now stop. What evidence do you have that it's really an eclipsing binary? And what evidence do you have that the period and ephemeris are not known? Check the other catalogs, check GCVS, check the OC diagrams. Check all the sources you can, probably starting with VSX. Make sure that it hasn't since been established as some other kind of star, or maybe it already has an ephemeris and period that you can trust. I would probably hit it a few times anyway, but if you don't know anything, then start with some kind of guess on the magnitude from the best source you can get, and just start measuring it. Consider a cadence of 15 or 45 minutes. Again, irregular is great. Fast slewing helps. So if you've got a 24-inch on a mount that takes 3 minutes to slew, this probably isn't for you because you're trying to fit in single observations between other ones, maybe in different places in the sky. And here's a practical hint that only comes with experience. This whole process is less discouraging if you pursue more than one of these at one time. Interleave them. That way you're more likely to get a success and stay encouraged. It's just like the worst thing you can do when you're looking for a job is to apply for one at a time. Now, apply for 5 or 10. You only care about the one you succeed at. And that's really all I had. I'm open to questions. Thank you so much.
Thank you very much, Eric. While everyone else is deciding whether to raise their hand, I got a note from Wayne Green who said, I have an idea. Share it with the troops, Wayne.
Okay, can you hear me okay?
Yes.
Yes.
Okay, I actually switched headsets in the middle of this since this is a test zone. In these PowerPoints, if you do them on a laptop and they work, then you move them to a dual screen. There's a thing on there that you have to mess with, and I can never remember where it is because I hate Windows. But that was probably your original problem, was getting the right screen displayed during the event. So I'm going to recommend, just based on this for seminars in the future, that people use a PDF rather than try to use PowerPoint directly.
Huh.
Anyway, that's all I got.
Thank you, sir. Any other questions from the audience? If you click your raise hand button, I'll find you on my screen and unmute you. Looks like everybody's being shy. Oh, wait a minute. Ed Wiley. Well, no, it's not letting me unmute you, Ed. I don't understand why. Oh, because you're muted on your end, Ed. Oops.
Path of a common sharing of spreadsheets, maybe with some worked examples, so we can integrate some of these things into our own programs. Did you hear me?
I heard you.
Okay.
So who has ideas about sharing these spreadsheets? Oh, Eric's video, I think, has gone to sleep.
We can follow up later.
Okay. Eric, are you hearing us? No, it looks like he had an internet problem. Yeah, you can follow up with Eric, or if you don't have his email, Ed, send me a note and I'll pass it on.
I can message him. I can message him on the forums.
Okay, cool. Any other questions or comments from the audience? Okay, I'm going to try an experiment since we don't have any other questions for a moment. I'm going to unmute everybody on the audience so that you can all say thank you to the presenters.
Thank you.
Well,
Yeah, thank you very much.
Thank you, guys.
You're welcome.
Thanks, guys.
Thank you.
Thank you.
Thank you.
Thank you.
Oh, too many people. We are not keeping the social distancing here.
and for those of you on the audience, I think I have the system set so that in about an hour, it will send you an email asking for any comments, positive, negative advice for when we do this again. I'd appreciate anything that you have to say. I guess that concludes this session. Thank you all to our presenters. Thank you very much for the audience. I had a good time. I hope everybody else did too.
Oh, Eric's back.
Thank you, Eric.
Back.
I was busy
Thank you.
taking notes there, so I was getting stuff from Jerry and Sebastian. That was quite useful.
Yeah, we just lost internet connection for some reason. Go ahead.
All right.
So I had a couple.
Go ahead, Gary.
Bob, is there any way to show everybody on this thing instead of just the presenters?
As far as I can tell, no,
Okay.
but I will look into that. Gary? You're happy? Well, guys, thank you very much for volunteering to do this. I think we had a successful experiment here. Oh, Bert, did I ignore you? I see your hand waving, but I don't hear you. I'm still not hearing you, Bert. Oh, it says you're self-muted.
Okay, now it's letting me unmute.
Great.
Earlier it was just like you muted everybody, so I couldn't unmute even though I tried.
Ah, okay, lesson learned.
I just wanted to say a couple of things in closing to everyone. I'm really happy that everybody showed up, and I hope you all got something interesting out of this whole presentation style. I actually really liked it for the most part, aside from a few technical difficulties, which honestly you're always going to have in new settings, especially. But I kind of wanted to get, if I could, so Ed's comment was great. It's something that we can definitely look into, but I'm looking for more things that we can look into. So from the Eclipsing binary section, what is it that you guys would like to see more of? What information would be useful to you? Do you want new types of projects? Do you want new analysis tools? Like what are the things that you are looking for? Because we can really tailor this to you as much as possible, but we kind of have to know a little bit about what it is that you want out of this whole thing. So if anybody has any ideas, you know, you can feel free to speak them now, or you can also yeah, I think when Bob did the auto mute, he muted everybody, and I don't think they can unmute themselves.
I think I messed something up here. Yeah, you're right. Keep clicking the button to unmute you guys on the panel. Oh.
Eric Dose managed to, I think.
No, I can't see anything.
Okay. This time I was able to unmute myself. I haven't been for a while.
Yeah, I think Bob has to unmute first, and then you can unmute yourself after that.
Yeah.
Is the idea, which is a little bit strange, but yeah.
In response to your question, Bert, one thing that I always wonder about is, am I observing a star that's actually going to be of interest to researchers? Now, I know that we can never predict that completely. And, you know, one school of thought is all observations are useful, but I actually think that probably some are a little bit more equal than others. So feedback from you or other professional astronomers to say, yeah, this one is doing something interesting, but we really understand it well. So, you know, don't devote your life to that. But this one over here, that's one, you know, or ones like it could be super interesting. that kind of feedback I would be very interested in.
So one thing that I can do or one thing that I've been planning on doing for a while, and honestly, it's just been hard to get the time to discuss it with people, is to talk to individual researchers and ask them for specific projects, things that are long-term, not things that would go into campaigns per se, but things where it's like, okay, well, we need observations for a few years on a random assortment of things. And the project would be detailed, it would be outlined, it would be on the observing page, so it can say, hey, if you observe these things, I really care about these stars or this set of stars, and this would be really helpful to me, and I will give you regular updates on how this is going. So that's one area in which, or that's one way I can do it. As for, looking at specific stars, it's a little bit more difficult to say, okay, well, I care about this star, I don't care about this one. Some people will definitely tell you, like, hey, if it's, a Wolf-Rayet star in a binary, then I care about it. But other people are just like, well, it really just depends on what the star is doing. So, so I think the easiest way to get that sort of information would be to allow people to present projects that you could then decide to work on or not, as as to what you find interesting.
Okay.
I can provide the Eclipsing binary section with some interesting targets that I find when people made some discoveries and submit them to VSX, and I see them, I see the light curves, so I can take advantage of that and let you know, guys, when there is something out of the ordinary, something interesting. So I have a couple of examples, so I will send you a list.
Yeah.
Wayne Green sent me a note. Wayne, I'm going to unmute you. He's asking about a TAP interface to the database.
Yeah, Bert, that would be handy if you could hook all this data up through TopCat, say.
Oh, I know vaguely what TopCat is. What exactly are you asking for?
I've been building a database of reference spectra, for example, nothing to do with eclipsing binaries. I was able in TAP to go through and take the listed ID star names, which, as you know, are all over the map. I mean, everybody's got their favorite name. I was able to upload that into Simbad and get the complete list of all names, therefore bringing down things like the HIP, the HD, and so forth IDs, and then merge that back together in my own local database, all from within TAP, hooked up to PSQL on my local machine. And I've done that in a number of different places through the Gaia data, through PanStars, et cetera, et cetera, et cetera. However, AAVSO is rather opaque in that regard.
So we do have some tools for that work through VSX. So for instance, you could put in a star name, it would query VSX, find all stars of that name, find the AUID, and then allow you to download the data in that respect. It doesn't have all star names, but it has all of the ones that are in Simbad, as well as a few others that are not.
Well, that's the way I've been doing it now through AAVSO, but it requires specialized knowledge of AAVSO. Not that special, but it takes a minute to acquire it. Whereas going through TopCat, the interfaces are virtually seamless. In other words, you learn one, you've learned pretty much all of them. And it ties into the 24,000 databases that Aladdin supports. TopCat through SAMP and XXP ties into DS9, my favorite tool, and others of that ilk. So you can do some incredible research. We found targets on the fly, on a Mac, in an office, in an afternoon, just by having that availability. And we avoided AAVSO just because we didn't want to take our mind off of what we were doing to go after that particular aspect of it. I think what you guys are doing are really great. You're sitting on an awful lot of data. If we could find a way to put that more into the data informatics sphere, man, you could build a career around that.
That is definitely something to consider, and I won't dismiss it. It isn't easy. What you're talking about would require a significant programming effort on our end or on somebody's end to put it into the right format for this specific set of tools. I don't know what's involved with that, but I can at least put it on the list to look into and see how difficult that would be.
Okay, well, I know there are a number of institutions that you could probably make a few phone calls to, and those people would be able to give you a very quick and deep insight into how you might adapt. I think it might be a little easier. I know you guys use MySQL for the most part, right?
Mm-hmm.
Okay, yeah. It's come quite a long ways, and you should be able to have some successes with that. So I encourage that, and thanks for all the other data.
Cool. Okay, at the complete opposite end of the spectrum, Gregory Conrad is asking, what about thoughts for a novice? Gregory, would you like to elaborate on the question? I've got you unmuted if your mic is working. Well, I guess not. On the panel, would anybody like to talk about the novice observer and analyst? Any sage advice?
Well, I would say go to Jerry's ephemeris. Jerry here talked about the legacy stars. I don't think either of us mentioned that he makes an ephemeris every year for all of those stars that will has a certain amount of success built in that they are accurate predictions of when the eclipses are going to occur. And if you're new to eclipsing binaries, I would say, you know, start out by observing something where you're actually going to get an eclipse, and there's enough other data out there that the accuracy of your results can be assessed. You know, you can deal with things like heliocentric corrections if that's what you're going to do, and so on. I'd say that's where to start. Jerry, what do you think?
Well, that's always a good plan, and I know a number of people who have done that, where they start off by observing stars that are well observed, so we can look at their observations, make sure we have a fit. I will point out that on the ephemeris, the predictions are rounded off to the half hour. This is somewhat of an artifact of the visual era when we didn't want to give people too accurate a prediction to bias them. And the reality is, as I've shown from the O-Cs, we get enough fluctuations that I'm not going to promise more than a half hour accuracy anyway.
Well, I think that's really good though, because you're going to make an observing run of 4 hours or 5 hours. So half an hour uncertainty is minor compared to what I'm used to, where I might not see anything. So,
well, I'm going to disagree with that. Actually, I think that the ephemeris that a novice uses should be absolutely as accurate as possible, so they know if they got it right or not. Half an hour is not good enough for the observations we'll be asking people for over the years.
Well, my opinion is that I can't predict them that accurately because the stars usually don't cooperate. The stars themselves are changing periods often enough that I never can predict it to the minute.
No, but you can predict a lot better than 30 minutes. I'm usually within 5 minutes.
we could identify an eclipsing binary or two that we don't think has any period variation, and you know, get accuracies of a minute easily. You know.
Well, that's a point. Some of the other sections have a list of 5 or 10 stars to begin with, covering the zodiac, so you always have 1 or 2 available at any given starting month. Might be a good thing here as well.
But you have to take into account this heliocentric correction, because even that's going to give you that 8-minute fluctuation between quadrature and opposition. So the ephemeris, I don't take anything. I don't take the Earth's orbit into account.
Yeah, having a list of 5 or 10 novice-friendly stars would still be better than having them guess and pull it out of a hat or out of that list of 2,000.
Yeah, no, the list I use would not be suitable.
I understand.
Yeah.
Can I make a comment?
we've got a comment from Ed Wiley here.
As a relatively novice eclipsing binary person, my reaction is that since you have to start, I start an hour before the predicted eclipsing time, and so 30 minutes one way or the other. In fact, sometimes I start 2 hours before the primary eclipse, so 30 minutes doesn't bother me. The other thing that I would encourage beginners to do, which is what I've started in my own process, is learning how to do their own times of minimum and doing them correctly with heliocentric Julian dates. And then also think about, instead of just shoveling these off to the professionals, think about publishing your own times of minimum. There's nothing, as someone who's been 40, 50 years in another branch of science, there's nothing like hooking someone by seeing their name in print, and I would certainly encourage that. Thanks.
Well, we do publish times minimum in every journal AAVSO, so that papers come out twice a year.
Right, but I'm talking about with their authorship. The observers.
Well, I guess that's up to the observer to publish then.
I'm sorry?
I guess that would be up to the observer if they want to write their own paper.
What I'm saying is that this hooks people onto the research program when they're able to follow through from observation to analysis to publication. That tends to keep them in the game and keep them interested.
I'd like to make one more comment about ephemeris in general. When you look at our ephemeris, it has a number for eclipse duration, which is not the complete eclipse. It's more the number of hours you probably need to observe to get a decent time of minimum. But there's also a second line below that that gives you the duration of the totality. Now, if you get, like I mentioned, the V342 Aquila, it's got a 3-hour totality. So if you start an hour ahead of time, all you're going to observe is the totality. You're not going to observe either the rising or the declining leg. So you have to look at each star individually to make a decision as to how much time you need to spend observing it.
In addition to submitting papers to the journal of the AAVSO with your timings, Jerry Foote is pointing out that you can also submit them either as a paper or a poster to the SAS. And Wayne is making a suggestion about high ecliptic inclination candidates. Wayne, would you? Oh, you're muted. If you'll unmute yourself.
Sorry, this whole thing. Okay, so if you have high inclination to the ecliptic, that basically means you don't have any real offsets due to the relative positions, the heliocentric corrections that you need. And so I think what Eric is proposing is having just a small handful of candidates. Algol kind of falls into that class, you know. And the only other thing I'd recommend, and to back up Eric a little bit, is something that Bob Buckheim and I have talked about, and that's something I call steady star photometry. That means stare at one that doesn't vary and make sure that you're not seeing variability. That's all. I do that from time to time just to make sure my equipment's telling me what I think it is. Anyway, high inclination stuff should be easy to select for in the database.
Let me find Jerry. I've unmuted you. Would you like to elaborate on publications?
Well, we have many observers who do write their own papers, publish their own times of minimum. I basically publish papers containing mine plus anybody else who doesn't want to go through the work of doing it themselves. And so what I do is ask them to send me a copy of their observations. Now, you'll send it to AID and then send me a copy and I'll do the analysis and get them published. I do send the electronic versions to the Brno O-C gateway as well as the Elliptic Connector database. So we try to get this information out there where everybody can see it.
And Jerry Foote, you suggested SAS?
Yes, this year is probably not a good one. We're a little bit late to taking an abstract, but consider publication in SAS. it gets indexed, and your information will be out in the public domain, along with all the other locations that it should be.
Actually, as far as that's concerned, I would recommend that observers only publish in one place. Otherwise, what tends to happen is you'll see in the databases the same time of minimum repeated several times for each publication, and it really skews the statistical analysis.
Yeah, that's a good point. You publish it once somewhere.
Yeah.
And Gregory Conrad, Greg, would you like to offer your appreciation to Jerry Samolik? I have you unmuted on my end. Gregory had typed in a comment that he really does appreciate Jerry's efforts in this regard of making sure that the publications give attribution to all the observers. Gregory has no mic. That's why he can't talk. Any other comments or questions from the audience? I don't see any more hands raised. Well, we've been here for a little over an hour and a half. I think this has been a lot of fun.
Yep.
Thanks for organizing this.
Yeah,
My pleasure.
Bob, thanks very much for organizing this.
My pleasure. Well, thank you all in the audience. You have a good day. Panelists, thank you very much. I'm going to push the stop recording and stop the meeting button. And panelists, I'll send you a link to the recording so we can decide whether it warrants seeing the light of day.
Okay.
Y'all have a good afternoon.
Take care.
Thank you. Thank you very much. Bye.
Thank you.
Bye-bye.